Students, welcome to the lecture series of Object Oriented Programming. In this lecture, we are going to see C++ streams, why we need streams, and some of the predefined C++ streams. At the end of this lecture, you will be able to introduce and use streams. As we know that every program takes some data as an input and generates processed data as an output following the input process output cycle. We have already used cin and cout with the operators such as extraction and insertion for the input and output operations, but we don't know how to control them. C++ supports all of the C's rich set of input-output functions for use, but we do not use them because input-output methods in C++ supports the concept of object-oriented programming. Input-output methods in C cannot handle the user-defined data types such as class, objects, and so C++ uses the concept of stream and stream classes to implement its input-output operations with the console and disk files. C++ streams. The input-output system in C++ is designed to work with a wide variety of devices such as terminals, disk, and tape devices. Although each device is different, the input-output system supplies an interface to the programmer that is independent of the actual device being accessed. That interface is a stream. The stream acts as an interface between the program and input-output devices. A stream is a sequence of bytes. Stream acts as a source from where input data is obtained, and stream acts as a destination to which output data can be sent. Let us see the data streams. If you want to take some input from the input device, and if we have some program to process on that input, then of course from that input device the input will be taken and it will be stored temporarily into the input stream. Input stream is the source stream that provides data to the program, and data in the input stream can come from the keyboard or any other storage devices. After extracting the data from the input stream, program process on that data and it produces some output. Then after producing the output, it inserts that data onto the output stream. The output stream is the destination stream that receives the output from the program, and the data in the output stream can go to the screen or any other storage device. And of course that storage as I said, the output device can be a screen or any other output device. A program specifically extracts the bytes. The program extracts the byte from the input stream, and it inserts the byte into the output stream, and finally it goes to the output device. Now let us see why we need streams. A stream provides a standard interface for using the diverse kind of equipments. As we know that we use the different devices such as disk files, sockets, keyboards, or video screens as input or output devices, and they have different properties, needs, as well as machine language. All these differences are hidden by the stream interface, allowing the programmer to use one set of functions to read or write from any of these devices. The second is streams provides the buffering. An input stream buffer stores the block of input characters and delivers them to the program one line or one character at a time, whereas the output stream buffers stores the characters that come from the putS, printf, or cout statement until even have been collected to write a whole line on the screen or a whole block on the disk. The third is error flags. This is the most important way to use the stream. Why we use the stream? A stream is a data structure used to keep track of the current state of input-output system. It knows the location of source or target device or file. It knows how much has been read from or written to the device into the buffer. It knows how much data has been read from or stored into the buffer, and this stream contains the status flags that can be tested to detect the errors, and hence we need the streams. The C++ streams are divided into two parts. The first one is predefined C++ streams and the second one is programmer defined streams. There are four predefined streams in C++, such as the standard C++ input stream, that is Cin, the standard C++ output stream, that is Cout, the standard error stream, that is Cerror, and logging to a file, that is clog string. Let us see it in detail. The Cin stream, that is the standard C++ input stream. It is Cin and it is connected to the user's keyboard almost all the time, but some of the times you can connect the other input device also. Most system permits that Cin to be redirected so that the data come from a file instead. The second stream is Cout stream, and that is connected to the monitor or to the user's video screen, and that Cout is the C++ standard output stream. Most of the times that output stream is connected to the video screen, user's video screen, but it can be redirected so that the data can go to the file. The third standard error stream is Cerror, and it is usually connected to the video stream or the video screen of the user, and it can be used by the runtime system to display the error comments. Any program can write any program can write output instructions or error messages into the Cerror. The error stream normally is connected to the user's video screen as I discussed. All those standard streams are open automatically when your program begins execution and close automatically when it terminates. The Cin is connected to the keyboard by default as I told you. Cout and Cerror are connected to the monitor by default as I told you, and these all the default connections provide excellent support for the interactive input and output. So these are the simple four predefined C++ streams which are available, and these streams supports the excellent support for the interactive input and output without disturbing the devices which are connected to the program. I hope you have understood this. We will meet in the next lecture. Thank you. Happy learning.